So these notes are from chapter 5. We're going to go through section 5.2, and I'm going to post homework number 6 this Thursday for this section. And we hopefully will do 2 homeworks for graph theory. So today we're going to talk about loops, multiple edges, and degree. So, good morning. Thank you for coming to the meeting. We are starting on 5.2, section 5.2. So a edge that connects a vertex with itself is called a loop. So the first example, we'll have just one vertex. Let's call it X. And we'll just go around back to X. The vertex is like singular, so there's just one vertex called X. And there's only one edge, X, X. X goes to X. So one more example for loops. So that was the first graph. The next graph is a triangle, and one of the corners has a loop. Let's call this A and B and C. So if there's more than one vertex, they're going to be called vertices. And the vertices are A, C, and B. Edges are going to be AA, AB, AC. So there's the loop, AA, edge, AB. Uh-oh, I'll be right back. Okay, laundry on hold. So, AA. A goes to B, A goes to C. BC, and I think that's it. Let's check. BC, Do we have CA? Yes. BA, and there's that loop, AA. Next, we talk about multiple edges. So this is an edge that goes from one vertex to another, and it happens again, and it happens again, multiple times. Cool. So we are going to say that edges that appear more than once are called multiple edges. Cool. So we have a new graph. With Q, R, capital R, S, T. We connect Q to R, and we'll have R go to S 3 times. So there's 1, 2, 3 edges. And we'll also connect to S with T. Okay, let's do a little labeling here with multiple edges. And this graph are right there. All right, we want to list our S, T, and Q. The edges are going to be QR, RS, 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 ST. Let's do this. So when it's listed multiple times, there are multiple edges, or if there's a connection between 2 vertices more than once, those are multiple edges. And this is really just a side note that if a graph has no loops and no multiple edges, then it's a simple graph. Okay, let's do this. Simple graphs have no loops, no multiple edges. Just graphs that we will work with are mostly simple graphs, but for practice on some of the problems, we're going to draw some loops and draw some multiple edges. But for the most part, we're not going to have those in our graphs. we've gotten to doing a bunch of examples, and then we'll cover degree, do some more examples. That's our plan. Number 1. We have M going over to L. L has a loop. Cross over this way to I. And that way we have K. I is connected to K. And over here, we're going to draw one more J. With 2 edges, JK and JK. Cool. So for this graph, we have M, I, K, L, J as the vertices. And the edges. Let's do M to L, M to K. Let's go down over here. I, L, I, K. Let's take care of this. So L goes to M, which we've already listed. L goes to L, which would be written like L, L. Loop. And then L goes to I, which is right there. Cool. Let's go over to K. There's KI, which is listed. KM is right there. KJ, and another one, KJ. Okay, so next graph. We have E, F, and G. We connect E to F 2 times. E goes to G and F goes to G. And we want to practice finding all the vertices, finding every edge. Make sure you don't have any repeats. So E, F, and G are our vertices. Starting with E, E goes to G. E goes to F 2 times. We already have FE, FE right there. FG needs to be listed. And just checking, GF, got it at the end. GE is at the beginning. And we're good. Back to where we started. Okay, so just pointing out that EF, EF, those are multiple edges. For graph number 3, let's see. We're going to have, let's call this A, B, C as the vertices. And there's a loop and a loop. Let's list the dots or vertices. And the edges, starting on this side, A to B. AB. BB is that loop. And BC. CC. Number 4. Ready? This is, let's say this is X and Y. Call this C and W. There's XW. In between XY, 2 edges like that. Same for XC, cross over and back. So the vertices are the dots. Just list them out. Edges. Let's start here with YX, YX. And then X goes to Y 2 times, which we've already taken care of. X goes to Z 2 times, so we need X, Z, X, Z. And also XW. And graph number 5 will be kind of a bunch of loops. Okay, so let's just checking on that last one. It was W, Y, Z, X as the vertices. Edges are YX, YX, XZ, XZ, XW. These ones are going to be labeled L, M, with 1 loop and 2 loops. You list L and M with edges LL, LM, MM, MM. So we're going to kind of change a little bit and talk about degree. We need to find those notes. So the degree of a vertex is the number of edges that meet that vertex. It's written like this. Meet. So let's start with something simple, like this example. For a graph like this, we'll go from this dot over here and over there and again with one more here. Okay. We're not going to label the vertices. We're just going to label the degree of each of the vertices of each vertex. So starting at the top, there's only one edge connected, so that's degree 1. It also helps to maybe draw a little bit like on each of the edges. So from here to here, there's one connection, and we're going to write this as degree 1. Here we have 2 connections, it's degree 2. And this is connected 1, 2, 3 times, it's degree 3. There's one connection there, it's degree 1. And the last one is degree 1, just one edge connected to that vertex. So that's one way to do the degree. If you're working through a problem and you just need some scratch work for finding the degree, I would use this shorthand. But we're also going to use some notation, like for this graph. Let's call this X and Y, Z. Let's go X to Y, Y, Z, we're going to write degree X as DEG parenthesis X. Degree of X equals just one connection, so that's degree 1. The degree of Y, that would be 1, 2, 3. And you'd write degree of Y is 3. Last one. The degree of Z is 2. It's just 1, 2 edges. Okay, so we're going to do like 3 examples for this and call it good. So the first one is without labels. And we draw like maybe down here. Let's just call it a graph. With a vertex that goes here. This vertex comes up and has a loop. Then we go back down to that connection and multiple edges, and we're good. So right here is one edge connected to that vertex, so degree 1. Ooh, you need a note here. A loop adds 2 to the degree. So we're going to do 1, 2, 3, degree 3. This vertex has degree 1, 2, 3, 4. 4 total. And the last one is degree 2. I'm going to draw. D, X, with this loop. Let's put R and then connect to D and X. Over here is H, which connects to R twice. And then we get the degree of X. Degree of H. Degree R. Degree of D. Okay, so find the vertex X. Its degree is 2. There's 2 edges that connect. H is right over here, and it has 2 connections, so its degree is also 2. R, there are 4 edges, 1, 2, 3, 4, that connect to that vertex. So it has degree 4. And D has degree 2. There's 2 edges there. We're gonna do one last one, and we'll try to draw it very carefully. It's kind of a big graph, so. Let's do this. So start with just all of the vertices, and the first one is at the top being S. Come down a bit and have N. Straight over, put a dot, labeled T. And then we're going to go down from N and have G. A little bit further down, we'll put L. And kind of like it's almost like a circle, kind of, with A right about here. Starting at T. T connects to N. T goes to G. T goes to L. And T goes to A. We need a line from A to G. And now let's start at S and have S meet G. S connects to G, and S connects to L. So we're going to connect N with L. And the last part is to put 2 loops off of S. That's the graph. Degree of S. It's written D-E-G parentheses S. We find degree of T. Let's find the degree of N. Degree of G. And degree of L, degree of A. So S, the loop will add 2 to the degree. So that's 1, 2, 3, 4, and then 5, 6. 6 total. T is right here, and it has degree 1, 2, 3, 4. Over here, find your vertex N, and its degree is 2. Okay, for the degree of G, make sure you're at the vertex G, and there are 1, 2, 3 connections. So G has degree 3. L also has degree 3. 1, 2, 3. And A would have degree 2. Just once, twice. Then we'll work on more practice problems like that next time. Cool. So thank you for coming to class.